Mrs. Hanvey here. All right, so today's lesson, we're going to talk about inverse trigonometry. And so how to use the inverse of sine, cosine, and tangent to find the missing angle in a right triangle. So before we used it to find a missing side. So for example, we were given something like this. We knew this was like 14 degrees or something like that. And then we had to find a missing side. I don't know. I'm just making these numbers up. So we would go, oh, we need to find the length of this side. So we'd use our trig functions. Well, this time, what's different is we're going to be given a right triangle, but this time we need to figure out how many degrees is the angle given our two sides. So let's say this is 7 and this is 5. How could we figure out what that measure angle is? All right, so that's our goal today. All right, so remember SOHCAHTOA. So we're still using SOHCAHTOA. Remember, this is sine of your angle is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. So hopefully you remember SOHCAHTOA. We're going to use that same kind of thing. But we're going to be doing inverse trig functions. And so you should be able to find these on your calculator. And it says sine with a -1 as the power. But this is how we say it. We say sine inverse, cosine inverse, tangent inverse. And so you'll notice they all have that little -1. It kind of looks like it's in the power. That means the inverse. All right, so normally, for instance, if we were given a normal trig problem, we would take our sine of whatever our angle is and set it equal to the opposite over hypotenuse. Remember, this is your angle measure. So it will be in degrees. So I'm going to put little degrees there, angle in degrees. And then this is your ratio, depending on the sides of a right triangle. All right. And so here's going to be the difference. The inverse, we're going to use sine inverse. And then we're going to actually put the opposite over hypotenuse. Oops, I totally did that backwards. So we're going to do the opposite over hypotenuse is going to be equal to your theta, or your angle. So how do we find our angle degrees? You would have to do the sine inverse of whatever the opposite side over the hypotenuse side. So that's your ratio of the sides of right triangle. Okay, so obviously this will make so much more sense when we do an example, so let's go ahead and get going to it. Before I do that example 1, I wanted to show you that you do want to use Desmos as a graphing calculator. Let me go back to desmos.com. And so make sure when you're using Desmos, don't use the graphing calculator. It makes it a lot more complicated. Go up here where it says Math Tools, and you're going to click on the Scientific Calculator. And hopefully you realize this is where sine, cosine, and tangent live. Those are the regular sine, cosine, and tangent. So how do we find the inverse ones? And this little thing is in my way. Hopefully it'll go away. So in order to find the inverse, you're going to have to click over here on this function button. So you click there, and hopefully you do see a whole bunch more stuff. And there's the sine inverse, cosine inverse, and tangent inverse. So we're going to be focusing on these buttons. So remember, you have to click over here. And remember, make sure it's in degrees, because we want our answers to be in degrees and not radians. This stands for radians. So make sure this says degrees. All right, here we go. All right, so we need to find the measurement of x. So what it's asking you is, oops, let's try that again. So what it's asking you is, how many degrees is this angle? We need to figure that out. And so, kind of like what we did before, we're going to go ahead and label our sides. So we know this one, why does it keep doing that to me? This one is going to be the side opposite, and this one is right next to the angle. Okay, we know it's not the hypotenuse. I guess we should have our right angle there. So we're missing our right angles. It's our right angle. So we know this is the hypotenuse side, but we're not going to use that. We're going to use these two sides because they're given to us. We don't know the length of our hypotenuse. So we know this one is the adjacent side. And then we go ahead and reference our SOHCAHTOA. So I'm going to write SOHCAHTOA over here. All right, so which of our sine functions, which one has adjacent and opposite, or opposite and adjacent? And so we know we're going to use the tangent because that one has these two letters in the name. All right, so here we go. We're going to go ahead and set it up. We're going to do tangent of x, that's our angle, is equal to the opposite, which is 9, over our adjacent. Oops, not adjacent. How many degrees or how long is that? That is 10. Length is 10. And then, so we need to get the x all by itself. There's the tangent there. So what are we going to do to get rid of that tangent? We're going to do the tangent inverse. So in each side, we're going to go tan to the -1. So it's kind of like multiplying and dividing. They're inverses of each other or opposites of each other. So tangent inverse and tangent are opposites of each other. So we're going to go ahead and do that to each side. Let me go ahead and write that in the next one. So we're going to do the tangent inverse of this side, and we're going to do the tangent inverse of this side. So I'm going to put tan inverse, and we're just going to write tangent of x equals 2, and we're going to do the tan inverse. So we basically just did the inverse to each side, 9 over 10. Okay, and I'm going to go ahead and put this in parentheses. And the whole point of that, why do we have to do this? Because we know that the inverse and the tangent, they cancel each other out, just like adding and subtracting are the opposite. It's kind of like the inverse operations. All right, so that's how we find our x. And so we know we're going to have to use the calculator and put this in to our Desmos calculator. I'm going to keep that. And so hopefully this works nice. Maybe not. I got to get my calculator back over here. There we go. And so we're going to go ahead and type in tangent inverse. And then we're going to type in 9 over 10. 9 divided by 10. And it goes ahead and it tells you. So let me just go ahead and draw here. It says that it is going to be 41.98. I don't know why this is writing so slow. And then we know that we're going to go ahead and we're going to have to round this up because it is 5 or higher, which means our final answer is going to be x equals 42 degrees. And this is just really slow. I don't know why. And it looks really sloppy right now. So let's go back to our slideshow and maybe it will be better. So x would be 42 degrees. And you can see it decided to write it over here. Whatever, we get the same degrees. So that's how you figure out how many degrees that angle is. It's 42 degrees. All right, I'm going to go ahead and do 2 more examples in the next video. So watch the next video for the last 2 examples.